Okay, this section is on factoring. Now, I'm going to present a slightly different method of factoring than you may have learned in the past. Okay, and if you've struggled a little bit with the method you've learned, you might want to try this one. Remember, it's always better to have more than one way to solve stuff, and this may be a better method for you. Okay, and it's the method that I learned and has worked well for me throughout my math life. Okay, so to start with, I want to have you recall the FOIL method of multiplying binomials. FOIL meaning first, outer, inner, last. So for example, if we're multiplying these two binomials, okay, we're going to multiply the first, x times x, okay, then we're going to multiply, and that's equal to x squared, okay, then we're going to multiply the outer, all right, and that's going to equal negative 8x, then we're going to multiply the inner terms, and that's going to multiply to positive 5x, and then the last, okay, and that's going to multiply to negative 40. Okay, and then we can combine a couple of like terms to get this as our final answer. Note that the last term, negative 40, is the product of positive 5 and negative 8, and the middle term, negative 3, is the sum of positive 5 and negative 8. Okay? All right, now let's work backwards to factor x squared plus 10x plus 21. Now we know that this is going to end up taking a form of x equals x plus a plus and x plus b. Okay, and these a and b are constants. And we know that the product of those constants is positive 21, and that the sum of those constants is a positive 10. Okay, so what that means is we need factors of positive 21 that add to a positive 10. Okay, now if we listed the factors of positive 21, they would be 1, 3, 7, and 21. 1 times 21 is 21, 3 times 7 is 21. And the two factors that add to positive 10 are 3 and 7. So 3 is the A and 7 is the B, or vice versa. Okay, and so then we can write x squared plus 10x plus 21 as the product x plus 3 times quantity x plus 7. And that is now factored. Okay. Okay, let's do this example. Once again, we know that when we factor this, it's going to take this form, x plus a times quantity x plus b. So now we need factors of negative 32 that multiply to negative 32 and add to a positive 4. Okay. Now factors of negative 32 are 1, 2, 4, 8, 16, and 32, and also negative 1, negative 2, negative 4, negative 8, negative 16, and negative 32. And what I'm going to do is I'm going to pair them up. Okay, so, and those are going to be the A's and the B's. So for example, positive 1 and negative 32. A times B, remember A times B has to be negative 32. Positive 1 and negative 32 multiply to negative 32. They add to negative 31. Okay, what we need them to do is to add to positive 4. So this is not the pair that we want. Nor is this. Negative 1 times 32 multiplies to negative 32, but it adds to positive 31. So that doesn't work either. So by trial and error, you just fish around until you find the right pairing. Negative 2 times 16. They multiply to negative 32, but they add to positive 14. And you keep on trying until you come up with this one. Negative 4 times positive 8. They multiply to negative 32, and they add to a positive 4. So that's the pair that you want. Okay, so negative 4 is the A and positive 8 is the B, or vice versa. And so our answer is quantity x minus 4 times quantity x plus 8. That's our answer. Okay. All right, let's try this again. X squared minus 7x plus 12. Okay. Once again, it's going to take this form. So we need factors of positive 12 that multiply to positive 12 and add to a negative 7. Okay. Now listing them like this, the factors of positive 12 are 1 and 12, 2 and 6, and 3 and 4, all positive. but none of those add to a negative 7. So none of those are going to work. But remember, we could also have these factors, negative 1 times negative 12, negative 2 times negative 6, negative 3 times negative 4. All these also multiply to positive 12. Okay? And this is the pair that also adds to a negative 7. So that's the winning pair right there. So negative 3 is the A, negative 4 is the B, and then we can write it as such. Okay? I find by listing the factors like this, okay, rather than trying to keep them all straight in your head, by literally writing them down, it makes it very visual and therefore easier to solve. All right, now let's do this example. 3x squared plus 10x plus 8. Now this is different than the previous ones because we have a coefficient that's not 1. We have a coefficient of 3 for the x squared. So this is going to be a little bit different. Now remembering our FOIL, first, outer, inner, last, now this one is going to take the form of ax plus c, bx plus d. A and b are factors of 3. Okay, a and b have to multiply to 3. All right, because ax times bx is going to be ab times x squared. So a times b is 3. Okay, the c and d factors or constants must add, or I'm sorry, they multiply to positive 8. Okay, and then the outer a times d and the inner b times c, they add to positive 10. Okay, so now we have to consider factors of both 3 and 8. Okay, so here's how I'm going to set this up. The factors of 3 are 1 and 3, and so I'm going to set them up on the left-hand side. Okay, fortunately, it's just 1 and 3, so that's the only ones I have to worry about. Factors of 8 are 1, 2, 4, and 8, and I'm going to set those up on the right. Okay, 1 times 8 is 8, and 2 times 4 is 8. Okay, and what I'm going to do is I'm going to kind of draw lines between this set and this set. For example, and this is just trial and error. Okay, let's try this. Okay, now one of these times one of these plus the other one times the other one must add to 10. So first of all, I'm going to multiply. 1 times 1 is 1, 3 times 8 is 24. I'm going to multiply those, and then I'm going to add these. Okay, now my goal is to get to positive 10. These add to positive 25, so those are not my winning pair. Okay, so I'm going to try something else. I'm going to switch them. Okay, multiply. 3 times 1 is 3, 1 times 8 is 8, and they add to positive 11, which is close but doesn't get the job done. Okay, so I try something else. Now I'm going to try this. 1 times 2 is 2, 3 times 4 is 12, and they add to 14. That doesn't work either. But check this one out. 3 times 2 is 6, 1 times 4 is 4, and they add to a positive 10, and that is my winning pair. Okay? So by listing the factors of the coefficient of x squared over here, and the coefficients of the factors of the constant term over here, it makes it visual. And that's the part that I like, because I don't have to keep so much straight in my head. Okay? All right, so these are my winning pair. Now, when I set this up, remember that this is going to be of this form. Okay? So in this case, 1 is A and 3 is B. Okay? And now I got to be careful because I have to pair the 2 and the 4 up correctly. The 1 gets paired with, because it's an outer, this one over here, 1 is paired with the 4, so 1 is paired with the 4, so the 4 is out here. Okay? And the 3 is paired with the 2, so that's out here. Oh, so that's there. And you get this. Okay? And you don't really need to write the 1, so you can write it like that. And that is your answer. Okay? So it makes it visual, and that's the part that I like. All right, what about this one? This one's more complicated. Once again, I have a a coefficient of x squared that is not 1, so it's going to be of this form, okay? Now, factors of 6 are 1, 2, 3, and 6, which I'm going to write like this: 1, 6, 2, 3. 1 times 6 is 6, 2 times 3 is 6. And over on the right-hand side, I'm going to write factors of negative 45, which are these, okay? And I'm going to pair them up. You know, there's lots of possibilities here. 1 and negative 45, negative 1 and positive 45, 3 and negative 15, negative 3 and 15, 5 and negative 9, and negative 5 and 9. So we have lots of possibilities to try, okay? Advice: stay away from the ones on the edge, so to speak. 1 and 45, the answers are hardly ever that, and they're also hardly ever 1 and 6. Most of the time, they're factors that are closer together. So start with the ones in the middle, the factors that are close together, 2 and 3, and then 5 and negative 9, negative 5 and 9. Okay, start with that, and work your way towards the ones that are farthest apart. Okay, and that's usually the faster way to go. Okay, let's try this. You know, trying all these possibilities ended up not working. We're going to cut to the chase a little bit. Multiply this, okay, and we get, our goal is negative 17. This one added to negative 39. That one didn't quite work. That one didn't quite work, but again, by sticking to the ones in the middle, eventually you'll land on this. So if you started with these, you would have gotten there faster. Okay? So they multiply. 2 times 5 is 10. 3 times negative 9 is negative 27. They add to negative 17. That's our winning pair. Okay? And then the A is 2, B is 3. Okay? Or it could be vice versa. But you got to be careful with the pairing now. 2 is an outer. 2 gets paired with the 5, so the 5 is going to end up way out there. The 3 gets paired with the negative 9. That's an inner, so that's going to be right there. So be careful how you place those. And that's a nice way of factoring. It makes it very visual for me. Yeah, works for me. I advise you to try it. See how you like it. All right, other things we can factor other than trinomials. Here we have a difference of 2 perfect squares. X squared is a perfect square, 25 is a perfect square. And we remember that property that a squared minus b squared equals quantity a plus b times quantity a minus b. We use this property fairly often. So this is one you want to keep on the front burner or the bottom shelf, so to speak, and keep it easy to reach because we use this a lot. All right, recognize that these are perfect squares, and it makes it very easy because then you just take x and then 5. Add one, subtract the other, done. Okay. All right, next example. 18a squared minus 98. Now the first thing I notice is there's a common factor of 2 in each of these terms. So I'm going to factor that out right away. Okay. And first term becomes 9a squared, second term becomes negative 49. Then I notice that 9a squared is a perfect square of 3a. 49 is a perfect square of 7. So we can apply the previous property, okay, and do the same thing. And so we get this now, okay, and that's our answer. So remember that property, a squared minus b squared equals quantity a plus b, quantity a minus b. That's a very useful property, and we use that rather often. Okay, here we have a polynomial, 4 terms, and we want to factor this. When I see something like this, and I don't see any common factors amongst them, so I got to go somewhere else. So I immediately think factor by grouping. Okay, look for common factors amongst the first 2, common factor amongst the second 2, and see where that leads you. Okay, for the first 2, I see a common factor of x squared. And the second 2, I see a common factor of 3. So I factor out the x squared from the first one, factor out the 3 from the second one, And I notice that each of them share a common term of quantity x plus 4. So then I can group those. Okay, and you're done. Okay. Okay, one more example to do, and that's using factoring to solve this expression. And here's where it gets useful, because here's where we apply it to real life situations. All right, and we're going to check the solutions. So this looks complicated, and it's a little bit involved. All right, so let's do this. And the first thing we do is we set this thing equal to 0. All right, and we can do that by subtracting 63 from each side, and we get this. Okay, now we have to factor this. All right, whichever method you like factoring, I like this method, setting up factors of the first one, setting up the factors of the second of the constant term, and I just start trying to pair them up until I get a goal of negative 38 after I multiply and then add. Okay, well, before too long, you'll arrive at this one right here. That says when we multiply, 8 times negative 7 is negative 56, 2 times 9 is 18, and they add to a negative 38. So that is my winning pair right there. So I can write this as this, 2 being the A, 8 being the B, or whatever. 2 gets paired with the 9, so the 9 comes out here. The negative 7 gets paired with the 2. I'm sorry, the negative 7 gets paired with the 8, so that's right there. And that is now factored. All right, so we need to solve this. Now we're going to take advantage of the zero product property. That says if you have a product of two terms that equals 0, then either the first term is 0 or the second term is 0. All right, so I'm going to set each of them equal to 0 and solve each one in turn. For this one, I'm going to add 7 to both sides and then divide by 2, and we get 7 halves. And for the other one, I'm going to subtract 9 from each side, then divide by 8, and we get negative 9/8. So these are possible solutions of this expression, but we have to check these. Okay? So we're going to check each one for validity. All right, so the first one, I'm just going to plug in 7 halves for x in the original expression. Don't plug it into the factored one, because if you made an error getting to here, then this will work, but it won't be the answer to this. So you have to check the original problem, okay? So plug in 7 halves for x. Let me get this. Okay. Now, 7 halves squared is 49 over 4. All right. And then now I can do some cancellation. 16 and 4, I can cancel that out like that. 38 and 2, I can cancel out like that. All right. And then 4 times 49 over 1 is this. Okay. 19 times 7 over 1. 4 times 49 is 196. 19 times 7 is 133. And the difference is 63. Boom. That works. So 7 halves is a solution. All right, now let's check the other solution, negative 9/8. So plugging that in here, okay, and doing a little work. Negative 9 over 8 squared is positive 81 over 64, okay. And then I can also do some cancellation, all right. I get that. And then over here, I can factor out a 2 from top and bottom, and I get that, 19 over 4. So then I get 81 over 4 plus, because the negative signs multiply to positive, 19 times 9 over 4. 19 times 9 is 171. And then 81 fourths plus 171 fourths equals 252 over 4, which equals 63. Boom. So that works too. So these are the two possible. So these solutions are valid. Okay. All right. So there you have it, factoring. There's one more example I can use that, and the computer will actually solve this expression without factoring. Okay, we're going to use Desmos. So if you take this equation and insert that into Desmos, which I invite you to do Right now, pause this video and insert this equation in Desmos and see what kind of graph you get. Okay, you get this graph, okay? And it intersects the x-axis twice, here and here. If you click on those points, the ordered pairs for that point will show up, which I have hidden right now, so I don't want to see it. And those will be the solutions, because this function, x squared minus 10x minus 140, is this graph, which turns out to be a parabola. If you zoom out far enough, you'll see that it's a parabola. And the zeros are where it crosses the x-axis, right there and right there. So Desmos solved this for us. If you just indicate, if you highlight those points, it'll give you those values. Which turns out to be these, you know. So these are the solutions. X equals negative 7.845 and x equals 17.845, which you could also get using the quadratic formula, okay? But we're not going to do that right now. So we can use Desmos to solve this as well, and that's how you do that. All right, okay. So now you are in our position to do some practice problems.